Okay, and I've also started the recording now. The purpose of this two trainings is to train members of the water quality monitoring program that Mill Creek Alliance runs on some of our procedures and how we do things so that everyone gets the same training and we're all ready to go when we get to start. Our first sampling event this season is March 13th, which isn't that far away. So with that, I'm going to just kind of start right in. Sorry about that. My buttons are stuck. Today's agenda is we're going to talk a little bit about what the Mill Creek Alliance is. Some of you are new volunteers and you don't know anything about our organization except for what little you've heard from folks to sign you up for this training. So I want to tell you a little bit about who we are, what we do, some of our accomplishments, our projects, some of our community engagement activities. You might want to get involved in some of those. Then I'm going to talk about why we monitor, and then I'm going to talk a little bit about how our program's organized and what some of the new changes are this year. For those of you who've been monitoring in the past, we've been trying to update the program and make some changes that make it more efficient and help us generate the highest quality data, and I'm going to talk about that. Then I'll talk about the meat of this, which is really your volunteer roles and responsibilities. And I'm going to go through the procedures for collecting samples from the field. This particular training, even though some of you have told me that you want to be lab volunteers, we're going to do lab on the job training in the lab. So we're not going to focus a lot on the actual tests that we do in the lab, but if you're interested in that, we're going to be giving you a lot more training, and we also have an opportunity later in the season. We're going to have the Ohio EPA Level 2 chemistry training if you want to get certified. We're going to talk about collecting a water sample and the ways you do that, some safety information, and then I'm going to talk a little bit about the EcoTester pH meters that we added on in November of last year, and I'm really excited about. We're going to talk a little bit about the collector app and some of the new things that we're going to do with it, and then we're going to have some questions. The Mill Creek Alliance, this is our mission. We champion the resurgence of the Mill Creek watershed as a natural and community asset. It's very important to us that the Mill Creek is a place where people can come and they can recreate, they can fish, they can walk along or take trips on their bike. Our three main areas that we focus on is restoration, education, and recreation, and water quality monitoring actually is the thread that connects all three of those areas. In 2020, this is just 5 of the many projects that we had going on. I just thought I'd highlight some different types of things we do. This year we did the litter getter project. We had litter getters in 3 different spots. This is a picture of the one that was up at Witten Woods. These litter getters were designed by a company called Osprey, and they basically are like strainers that strain litter out of the Mill Creek, and then we've got a project going on at UC where they're actually going out at least once a week, emptying these and then categorizing the types of litter that are ending up in Mill Creek. Coca-Cola funded this, and it's going to give us a lot of good information about how to reduce litter that's reaching Mill Creek. Coca-Cola Consolidated also came out, and they were one of many Mill Creek cleanups that we have throughout the year, and they're all listed on our calendar. You can see from the picture that we get all sorts of tires. I think there's a bicycle on that one, big sheets of plywood and lots of different things. So all of this comes out of the Mill Creek every year, and these folks also categorize and weigh what we pull out, and it's really amazing. We finished the Redding floodplain project, and here's some of the project managers that were involved in that project, and the project itself is in the background. This floodplain project was designed to, Mill Creek often escapes its banks and comes up and floods the adjacent property. And this laid back the land so that we made a wider channel before any floodwater could get out and damage the buildings and roads adjacent to it in Reading. The Sharonville Tributary Restoration Project was, you can see here, they were trying to reduce the erosion going along in this creek. It's flashy, so it floods a lot, and so they're hoping that this tributary restoration project restores, helps stabilize the stream bank, and also improves the habitat for aquatic life. And then at the end of the season, we did a Twin Creek Preserved Invasive Species Removal Project. We've got a couple of those coming up. Carlos is going to lead one in Solway on, I think it's March 6th. But these projects, we pull out the invasive species, and in Carlos's project, they're going to go ahead and have seed bombs so we can reseed it with desirable native plants. So these are kind of some of the things we're up to. On the community involvement side, we have service learning projects. This particular project up here was them basically planting live stakes that we had cut earlier in the season, and those were going to grow up to be willow trees that stabilize this bank here. We have urban stream adventures, and something you might want to get involved with. These urban stream adventures basically take people in the Mill Creek. You sign up, we provide the canoes and the paddles and the life jackets, and you get to take a trip down the Mill Creek and see it from the inside the channel, which is a much different view of Mill Creek. And also there's a lot of experts called the Mill Creek Yacht Club that will educate you about Mill Creek and all of the issues that face it and all the great things we're doing to make this river a really desirable place to commute. We have water quality education, where we take classes out and do water chemistry and macroinvertebrate type work so that people learn a lot about what the quality of the water is and what's living in the water. This is us. We monitor the water quality, and this particular photo is someone performing the total phosphate test, which I'll talk about a bit later. And then again, we have the trashathon and a bunch of different Mill Creek cleanups. This is Bruce Kaler, who's Commodore of our Mill Creek Yacht Club, and you can see how much they cram into these canoes and bring out of the Mill Creek. Why do we monitor? I don't know if any of you know a lot about the state of Ohio, but the state of Ohio used to be mandated to monitor every other year and report it in biannual reports. But they changed that, and now they do a report on different subbasins every 10 years. And they call that report a total maximum daily load study. But between those 10 years, there's not a lot of data coming in except for when agencies like, for instance, the Metropolitan Sewer District here does some of its own monitoring projects with somebody like the Midwest Biodiversity Institute. So what we're doing is we're providing consistent annual chemistry data, and that is to help us evaluate the effectiveness of our projects, monitor trends so we know what the river is like all the time, and we use this to supplement the periodic data collected by all these other agencies. We also use our data to proactively respond to federal mandates and changes to the Clean Water Act, and we also contribute as volunteers and people, and I'll share ways you can get involved in this, but on permit limits, that's how much you can discharge, what kind of pollutants into our streams. The designated use, there's 3 types: exceptional warm water habitat, and limited resource waters. And then beyond that, there's recreation designations, and our stream is designated as secondary body conduct, but you could have primary body contact, which is swimming. And we also contribute to water quality management. We educate watershed stakeholders about all of the environmental and economic benefits of the project, and we aid in watershed planning efforts. So the data that all of you volunteers collect is used in a variety of ways with quite a number of people, and it really makes a difference in managing and improving the water in the Mill Creek. This program itself started long before I joined it. In 2013, they had 27 sites. Today, in 2020, we had 58 sites and 15 teams at the end of last year. We sample on the second Saturday of the month, March through November, rain or shine. We collect our samples on Saturday morning, bring them into a laboratory where we have volunteer lab analysts and lab managers that help them process these samples, and then we report that data out once a year in something that's called the State of the Mill Creek. And the next State of the Mill Creek is March 3rd, and all of you will get an invite to that. It'll be a Zoom where Mike Miller, I, and Dave Schmidt will all talk about the Mill Creek and what we learned from this year's data. As part of that, we always compare it to what we've learned in the past, which is that trend data. So we look at, is it getting better, is it getting worse, what's getting better, what's getting worse, and what can we do about it? And we use this data to help us make those assessments. So that's really kind of cool. We do field observations with the collector app, but we're going to make some changes in that I'll talk about a little later. We analyze all of our water samples for 8 parameters, which I'll also go over a little bit more in detail later. And we share this data in a variety of ways. We have an online Mill Creek website. This was a snap out of our website page. Each one of these dots, some of you can see the numbers, represents a sample site. And you can pull up all the data back to 2013. I'm in the process of updating all that and getting it back up online. Riverbank is a regional database managed by Butler County. We contribute to that, and then Ohio EPA has something called eBiz, and it's part of the Ohio Credible Data Program. And if you become a credible data provider, you put your data into this database, and everybody around the state has access to that data and can use it in watershed planning efforts. So it's pretty cool. Here is a list of the parameters we test and the reason we test them. Now we do something, we call it the phosphate test, but eventually we mathematically convert that into total phosphorus. So the phosphate test and total phosphorus helps us look at erosion and agricultural runoff because it helps us look at fertilizers. And fertilizers are also found in when we eat food and we excrete food, we're actually generating fertilizer of a sort called sewage. And so total phosphorus also helps us understand if we have leaking sewer lines, leaking septic tanks, and other problems related to sewage. Nitrate is another nutrient, and it does some of the same things as the total phosphorus test. But these two things look together in a ratio gives us an idea of what the productivity is in the Mill Creek. Probably all of you have heard of harmful algal blooms. We haven't had any serious harmful algal blooms in the Mill Creek, but we've had some in the Ohio River, and we discharge into the Ohio River. So one of the things we want to see is us adding less nutrients to help these blooms grow in the Ohio River. When you have algal blooms, when algae is growing, it is competing with other things for oxygen. And so we can have fish kills and other things if we get these toxic algal blooms. And also the water isn't safe for us to drink unless they can remove this, because the blue-green algae that cause these have toxins in them that could be harmful to people. So that's the reason for us to do both of these parameters, so that we have an idea of what kind of nutrients are out there, if it was possible that we could have an algal bloom with harmful algae in the Mill Creek, and also lets us understand how to reduce our impact on the Ohio River. Conductivity is a measure most people don't understand. They think, what's electricity have to do with water quality? But pure water, you've always heard of don't put an electric device in the bathtub because it'll electrocute you. And that's because that electricity goes to the nearest ground, which is you. And conductivity, when we measure it, we measure the particles that are in the water that have a charge on them. And the higher the charge on these particles, the higher the number of conductivity, and it tells us things about any charged particles. So road salts, the two nutrients above, heavy metals, a variety of things, anything that has a charge on it will give us some conductivity that's higher. And so we're taking a look at whether the conductivity levels are what we expect from our background geology, which is limestone. So here we expect 400 to 600 ohms. And if it gets much above 600, we know we have a pollution issue we need to track down. Turbidity is how chocolate does the water look, and to determine turbidity, you have to actually pull the water sample out and look at it, because when you look at it, the Mill Creek, you're looking at the stream bottom, so it's always going to kind of look brown, but when you put it in your sample bottles, you'll be surprised at how clear the water is. Turbidity is really important because it's particles, and when sunlight hits the particles in the water, it warms up and it can cause oxygen, which is dissolved in the water, to evaporate back into the atmosphere, and it can really have a negative impact on aquatic life. Also, if you want to recreate, nobody wants to recreate in muddy water. pH, we all know that when we go down to the swimming pool that we want water that has the right pH or we'll come home itching. And oddly, aquatic organisms and people have the same preference. So we look for pH between 6.5 and 8.5. When we start seeing pH go up, it's usually because we've lost some valuable habitat and shade, because warmer water tends to be more reactive and have higher pHs. Coliform, very, very important. E. coli is what the state of Ohio uses to determine if a stream is suitable for primary and secondary body contact recreation. So these E. coli values that we're getting from our data tell us if the Mill Creek is safe for us to actually go out and canoe and recreate. Optical brighteners and invisible chlorophyll A are two parameters that got added in 2019. Optical brighteners is what makes your whites whiter and your brights brighter when you wash your clothes. And one of the reasons we look at these is because if we do have a sewage leak, or what we think is a sewage leak, we know it's probably from human beings if it has optical brighteners. If we find no optical brighteners, it could be just a big flock of geese and be a temporary situation. So this helps us distinguish between the two. In vivo chlorophyll A helps us close the loop on our nutrients because it tells us how productive our system is, because it tells us how much algae is floating in that water column. And the algal biomass tells us a lot about how healthy our stream is. In 2020, I sent this out to you. OKI put together a really cool map for us. I can't get it to blow up here, but when you touch this map on your, if you bring it up on your screen from the handout, you can hit the top of it and it'll have a bar that can go back and forth and blow this up. I could go to another screen and show that to you. See this little bar? When you press this plus sign, you can pull it across and get a closer look. So you can see this is some sites around the West Fork of Mill Creek, and then you can scoot it around until you can see where your particular sample is. And notice how these dots have a number in them. The number inside these dots is your sample number. And the color coding is actually your teams. So this tells us what team is sampling that site and what number that site is. And then this blow-up box is the name that the site's given in our data record. So this is a brand new concept for this year, and this explains a little bit about how we do this. And we put all these lines around these bigger units. These are the 12-digit HUCs that we do all of our watershed planning and management with. So this gives you an idea of how we use individual clusters of our sample sites in watershed planning. So pretty cool. I'm going to go back to our program. I was going to go back. So this new map is, all of you have a copy of this, so you can actually look up your sites and see how they relate to the other sites. Normally at our State of the Mill Creek, we have this on an easel so people can come up and look at it. And I've blown it up for meetings and other things, so you'll probably see that at some point at the lab. This program started in 2013, and until 2019, they added sites, but they never really took a look and evaluated how the sites related to what they were trying to do. And so we put together a group of people that sat and looked at every single one of the sites and how useful it was to our mission and our work trying to do all these restoration efforts. And we found that a lot of the sites that we retired were old sites from 319 grants that predated the formation of this project. Some of these sites were started in 2005, and they're all really close together, and they don't really help us with our work as much. And as we only have a limited amount of funds and time, we decided to retire these samples this year and add ones, and all of these additions relate to new projects that are going on in our watershed. For instance, Lick Run, 59, and 62, those are sites that the City of Cincinnati and MSD were interested in because they relate to the new daylighting of Lick Run. Sharon Creek and Sharonwood Parks relates to some new grants and projects that we're doing up on Sharon Creek in Great Parks. The West Fork of Mill Creek is related to some potential project work that's being done around Coleraine on the West Fork of Mill Creek. And then that tributary to Beaver Run, that's another area that they hope to do some project work at. So we were really lucky that people have picked up all these sites, and so this year we won't be doing 64 sites. We will still be doing 58 sites that we monitor, but our numbers will go up to 64. This summer, we actually got approached by the Metropolitan Sewer District and MBI who want our help, and I'm going to be seeing if I can get a call out to volunteers. If we can monitor 14 of their sites 6 different times between May and September, that will free up some funding for them to do some biomonitoring that hasn't been done in a long time. So we were trying to see if we couldn't do this. We found out that these 14 places are right next to where we're monitoring. So for 5 of the 6 sampling events, we're already collecting that information and we'll provide it to them. So we're going to have one special sampling event where we go out and collect from these 14 places so that we can give them the 6 sample sites. But MSD is one of our big funders, so we really want to try to do this. The other reason we want to try to do this is because we're part of the Credible Data Program and you're citizen scientists, and it's really an honor that they would ask us to work on this with us and to use our citizen-run laboratory for the data. Now I'm up to the part where I'm going to talk about stuff that's meat and bones to you who are doing the actual teamwork collecting your samples. This is a picture of an actual cooler that each team gets. We have you pick up one person from your team pick up the cooler in March, and we're in the process of getting those coolers loaded so that you can start picking them up next week, we hope. We think the best place to put these coolers is at the Upper Mill Creek lab. They're only open during the day, so I'm going to send out a survey to the team leaders to find out if they can pick them up there, and if not, I'm going to make arrangements to have a pickup day on another date so we can get all these coolers to you. The cooler contents, you're going to have large and small bottles for each site. And if you look in here, here's your large one, here's your small one. The large bottle is what we call wet chemistry. We do all but the fecal coliform using this wet chemistry bottle, which is 250 ml. We collect an additional 125 ml, even though we only use about 5 ml per per bottle for our sampling. And then if we need extra water, we've got it to finish our wet chemistry. Each one of your coolers has an ice pack. That ice pack, someone from your group needs to put it in the freezer on Friday so that you can pull it out and put it in your cooler on Saturday. That keeps your samples cool until you can get them into the lab for us to start processing. You'll have some paper data sheets in there, contact information for your team and the lab leader in case there's some issue, you're going to be late or something's come up that you need to contact us about. It'll have laminated directions for your eco-tester. It'll have your eco-tester pH meter. It'll have the pH standard, which is in a little pouch, some DI water, and we were going to put the storage solution, and we will put a little thing of the storage solution in there, but we're hoping that when you drop off the samples, you'll go ahead and put new cotton in the storage solution right at the table at the drop-off. We're also going to have laminated directions for the collector rack, a container that's going to hold that eco-tester, and pencils and a drying cloth, and we'll have a Ziploc bag with disposable gloves. We really encourage you to wear these gloves. You technically should change those gloves each time you move from one site to another. Although if you just wear them, I'm happy with that. Because we don't want, there are fecal coliforms in the water at different places, and we want to keep you all safe. Safety, I guess I always start with use your own best judgment. If, for instance, we have a weather event and we have flood conditions and it's not safe, we prefer people over samples. So if you don't think it's safe to sample, don't sample. We'll sample it the next time. We try to sample rain or shine, but not during really serious weather events. We ask that sample teams, if at all possible, work in groups of two or more. That gives you a backup in case somebody gets hurt or has some kind of medical situation. You have one person that can get some help. We ask that you take a working cell phone to call for help if needed, and that you program the lab leader's phone number into that, which is me. And make sure that you know if any of your team members have allergies or other issues that may be for the most part, people manage them, but if there is a problem, it's nice if the team members know how to help you and also how to get you help from calling 911. We recommend you dress for the conditions and you always wear sturdy shoes. I know everybody wants to go out in these water shoes that are open-toed, but I will tell you that one of the biggest water quality problems in the Mill Creek is flooding. And there's a lot of glass, metal, and other things out there, and we don't want you getting your feet cut up. So I always recommend that you wear sturdy, closed-toed shoes if you're going to enter the water. We recommend that you wear bright colors if possible, especially if you're sampling from a bridge so people can see you. And we recommend against wearing tan, especially in certain seasons of the year, because you look like a deer. We recommend you tie the buckets. If you happen to be one of the teams that drops the bucket from the bridge, we recommend you tie the bucket to something on the bridge before you toss it overboard. And the reason is that sometimes when that water hits your bucket, it can make a big tug, and then you can let go of your bucket and it'll end up downstream. So this assures that you don't get the bucket pulled right out of your hand. We always recommend that you park in a safe place and that you never trespass. Most of the places we monitor are public places. If you happen to be in one that's not, check with me, because some places we've already gotten permission from, but I'm not aware of permissions for all the places, and I will be happy to work with you on that. We always suggest that you avoid poison ivy. This is a picture of poison ivy, leaves of 3. Leave them be. We do have poison ivy. It tends to like the conditions around streams because it has evenly moist soil all the time. So you're possibly going to see that in a number of places along the Mill Creek. Wasps tend to, there are a type of paper wasp that likes to be out on these little branches like this, and they like to hang over water. So it's not unusual for you to be walking in there and have one of these be above you. So keep your eyes out and keep away from these types of nests. And bees, some bees also like to nest in the ground, especially in moist environments. So keep your eyes out, and if you see bees swarming around a place, it might be that that's the entrance to their underground nest. And then never approach a wild animal. I always suggest that you wear gloves. It's one way that you can assure that you're not going to get any E. coli in your mouth or in the cuts in your skin or any kind of infection. But it doesn't mean that you don't wash your hands after you've sampled. We always recommend that you wash your hands. But these gloves protect you from contamination, and then it's always recommended you use a new pair at each site so that you don't cross-contaminate your samples. Again, we're going to give you a whole bag full of different sizes when we give it to you at the beginning, and then when you drop off your samples, once you know what sizes your team needs, you can start adding more of those sizes from the table back into your kit. Make sure that you have the correct sample bottles. We really work hard to make sure that we look at the number and the descriptor and put them all in the right place. But before you leave, after you've dropped off your sample, you pick up your new one, make absolutely certain that you have your bottles for your team and that you have the right numbers on your bottles. Some sites we actually collect what's called a field duplicate. So you'll see a bottle number 4, and then you might see another bottle that says 4D. There's a big one and a small one for both. These field duplicates we use, we compare what your results are, and because they're field duplicates and water is flowing, they aren't going to be exactly alike, but they're going to be close. And the error rate in that is part of our CRAP, and we try to keep that error rate down. A while back, they thought that the collector app would be the perfect thing for field data sheets, but the state of Ohio still wants us to have paper data. So the only way for us to get paper data for a collector app is for us to download and print all those, and it's kind of an unwieldy job. So I'm recommending that we go back to paper data at this point, and that we use the collector app for something that's really going to be useful to all of us, and also to the Mill Creek Alliance, because we don't have it. I'll talk about that in a minute. But as I say, the paper field data are required for our quality assurance, quality control plan. This is something that's really essential for our program. This is what makes it a credible data program. You're going to complete and turn this in with the sample, one per site, even if you use the collector app on your smartphone. And what you can do, I'm going to have these available on the website. You can fill in most of this information yourself by typing it in, and then just if there's something unusual or different, we always need the weather and the precipitation if you know it, and if any of these conditions change, you can fix that. And then I want to remind people that this isn't on the collector app, but this is one of the more important things about the field data sheet to me, is other comments. If anything is weird at your site, we need to know about it. I've been doing water monitoring sampling since 1982, and believe me, I've seen some pretty weird things on the other comments. I've even seen bags of dead animals. I've seen deer carcasses. We've had barrels of chemicals that we had to take out and remove. But if these other comments are there, I look at them, and if there's something weird going on, we'll address it. So please use the other comments. There's two ways that you can sample. One of them is to sample directly from the stream. If you're sampling directly from the stream, remember to wear gloves. Notice this person has their gloves on. You want to collect as close to the center of the stream as you can safely do, depending on the flow. I don't recommend that you get any deeper than your knees when you actually wade into a stream. because if the water's really flowing, anything above your knees makes you unstable. If you wade into the stream, you want to stand downstream of where you collect the sample, which means that you're facing the flowing water. And if you look at this person, the water is flowing towards them. So you want to be facing the water flow when you collect that sample. Do not collect right up against the bank, and if there are going to be some conditions where maybe your stream is dried out and you have to collect from a stagnant pool, but for the most part, avoid that. And if you do, put that on your data sheet so that we know that the data might be different from that sample. You always want to take a representative water sample, and by collecting it in the flow, that's what makes it representative. Now when you actually get out there with your bottles, they'll be closed up and have the cap on them. You want to unscrew the cap, and then you want to rinse both the bottle and the cap, or the bucket in some cases, I'll talk about that later, 3 times with the stream water to be sampled. This is going to flush out anything that might still be in that bottle. We try to rinse them with DI water and everything, but this is a way to assure that the only thing that's in that bottle is the sample water. You want to avoid touching the inside of the bottle or the underside of the cap, because you could have something on your hands, bacteria and other things that might contaminate your sample. You want to fill the container up, leaving about 1 inch of airspace at the top. And we ask you to do that because there are some situations where you might take what's left and freeze it for other sampling at a future point. When you finish, you want to cap, and by putting your cap back on and placing in a cooler for transport. Now, what should you do with your cap after you've removed it? I recommend you put it in a pocket and not on the stream bank, because I can't tell you how many people have lost their caps because caps look just like rock. So if you can put it in your pocket and then pull it back out, if you do that, rinse it one more time with your stream water, and then securely put it on the top. If you're sampling from a bridge, this person is sampling from a bridge, they have tied it to the base here, and now they're throwing the bucket, here's the bucket, out here. And then when it gets down in the thing, they'll pull it back up, and then they'll dump the water out on the bridge, not directly down where they're going to be sampling from. You want to rinse that 3 times as well, and then the 4th bucket full, you're going to plunge those bottles into that bucket the same way you would plunge them into a stream, and then leave 1 inch of airspace and cap and put them in your cooler. Then you're going to transport them back to the lab. Notice this person doesn't have gloves on, and again, if you're not wearing gloves and you have any cuts or anything, or if you touch your face or your nose, it's an easy way to transfer bacteria. When you place the samples back in the cooler, make sure the ice pack is frozen. Drive the samples to the lab, and we'd like to get the samples by 10:30 a.m. if possible. The earlier the better. If you're going to be late and something has come up, please give us a call just so that we know you're coming and when you're coming. Now, when you get to the table, and we have a COVID procedure, we have a table outside to drop off your samples and pick up your new samples. You're going to sign this chain of custody form. It's going to have your site numbers already written down here. And so what you need to do here is you need to check that those are the samples that came in. For instance, if you went to site 47 and it was dry and you couldn't collect a sample, you're not going to place a check mark in this column. You're going to say who relinquished the sample. That's the person that shows up at the table. So 1 person or 2 persons' names go here. You can write the names to the top and draw an arrow to the bottom. This time is the time you actually drop them off at the lab. So we have we have watches out there, and we can tell you if you don't have a watch on. We want to write that there. The lab leader is the person at the table. They'll sign and draw an arrow to the bottom as well. And then this is important. Who else was on your sampling trip? You want to list all the names of the people that helped collect those samples here. And you're going to look for your team number. It'll have the samples that you're responsible for this year. because we'll update this, and that's how you fill that out. Once the samples are turned in, we will pick up your bottles and they'll be brought in here and put in order on a table, and we'll begin our monitoring process. This is Rebecca Key. She is one of our she's one of our interns who's a lab leader. She's in the process of preparing a fecal coliform sample. She's filling a colilert tray, is what it's called, with sample water, and it's going to go into a sealer here and get sealed, and then go to our incubator where it gets cultured, and then we'll count it on Sunday. I've covered a lot of stuff. Is there any questions so far? Can't see your faces, so I don't know. If there are, just let me know. This is the eco tester that we bought to replace the HANA meters that were just not working out. This is a picture of the HANA meter, and it is so easy to use. I think all of you are going to find it so much better to use than anything we used in the past. To use this, you press on, which is this circle here, and then to calibrate it, you're going to press this thing that says cal right here. Then you're going to stick the tip, you can see this is the tip, minus the cap, which you'll have already removed, into this little pouch. Once it gets into the pouch, it's going to start taking a measurement, and that's going to appear up here on the screen. This is the number that you'll see changing, and it'll stop hopefully close to at 7. It should, because it's 7.0 pH. And when that reaches 7.0 and becomes stationary, you hit this cal button again, and then you don't have to do anything else. You pull it out, you rinse the tip off with your DI water. This is the little bulb. You want to thoroughly rinse that out there, and then it's ready to stick into your sample and start sampling. Once you've done this at your first sample site, you just turn this unit off in between each place that you're going to go, turn it back on. You do not have to recalibrate it. Just turn it on and put it into the sample, rinse thoroughly, and then this will have a little cotton ball in the bottom. While you're out there sampling, you won't worry about the storage solution. We'll put that in at the end after we've rinsed it all off, and then we'll fill it up to this line. And I'd like you to try to keep those eco testers vertical in your bags, and I'm going to I've got some safety pins and some elastic. I know it sounds kind of simple, but you'll be able to use that little loop to keep your eco tester standing up vertically in between sampling one month to another. So couldn't be simpler. You'll get one of these pouches. In fact, I'll go to the next slide. You'll get the pH buffer and the DI water. If you want storage solution, we have a separate one of these that says storage solution on it. And then if not, what we really prefer is if you come back and we'll have this oaked-in storage solution and these cotton balls right there, and you can do that right at the table, which is much easier to do. Essentially, you'll pull the cap off, you'll pull out the old cotton ball, you'll thoroughly rinse this with DI water, you'll put a new cotton ball, which we found that about 1/3 of the size of this cotton ball works. But you want to be able to get the cap to snap back into position. And then you're going to fill this up, usually just to about here, because that tip is going to displace it, and you don't want it all the way up here, because that increases the fact that you might have some leaks coming out of your cap if you get much above the max line. So pretty simple and easy to do. People that I had everybody do it in November that could do it, and the reports back from people that tried it said it's super easy. So hopefully the rest of you are going to find that's true as well. Okay, the next thing is this collector app. For some of you, it's very complicated, and if it's too complicated, maybe someone else in your team can do it. But we want you to sign in, and depending on whether you have an iPhone or an Android phone, you have to use different directions. And so I sent you both the sets of directions. But this is the general directions that apply for both of those. You're going to have to sign into the Collector app. You're going to have to go on your phone to the App Store. The Collector app is free. And you're going to look for the Collector app for Arcgis. And then you're going to install that app. And once you open that app, and I've got a couple of screens, within the app, you sign in to the Arcgis Online. To sign into our actual Collector app application, you're going to put in public MCWCC. Notice these are all lowercase. You want to make sure that you type it in lowercase because this is case sensitive. Same with the password. You'll put Mill Creek 1 in and all lowercase with a 1. Once you do that, you'll be signed into the Mill Creek water sampling site. At that point, I'm going to switch to the next one, but your sampling site should be a little blue dot. And you want to make sure that when you're entering new data, that you press right on that dot. Now, one of the problems people are having with their iPhones is when you put your thumb on the rest of the screen, that makes another dot and puts your sample in another place. So you've got to be real careful that you're holding your cell phone in such a way that you aren't touching the screen. If you want, and you don't have to because you can fill it on the field data sheet, you can put your information in there, but then we have to print it out. But I prefer it on the field data sheet. To record or collect any data, you go to something called sampling info and add data and then submit at the end. But what I'm hoping that we do this year is that we're going to use the feature on this Collector app for taking photos. Because the one thing that we don't have from 2013 till now is good photos of all of our sampling sites. And these photos help us understand your site and can really help us do a better job of interpreting your data. So I want to talk a little bit about how to use the Collector app for photographs. We want folks between March and May to try to do this for each of their sample sites. And we're going to have you take essentially four photographs at each site and then go back to the same point the next year and do the same 4 photographs, and we'll be able to compare annually if the stream looks the same, looks different, and be able to see what's going on. So remember when I talked about upstream, downstream? You're going to start by taking an upstream sample. That means the water, in this case, it's flowing towards you. So I'm going to be facing this direction towards the upstream. And I'm going to take that all the way across the full channel of my stream. Then I'm going to turn sideways to my left, and I'm going to take a left bank, and my left bank is going to be this picture here. And it's going to show me the land uses that are adjacent to this stream bank, which is going to be really useful for interpreting the data. Then I'm going to turn and I'm going to completely face the right bank. And when I face the right bank, I'm going to also take a picture of this. That gives me the riparian zone and anything behind it, and that's the land uses that can help us interpret your data. Then you're going to turn around. Now the water is going to be flowing away from you downstream, and you're going to take a downstream picture of the full channel. Hopefully that makes sense. The Arcgis, this is on the handout that we gave you, and it's got all of the pictures of what you should be looking for, and it shows you how to sign into the app, how to click the profile for us, and then this is important, download and sync. You need to make sure that whenever you go on to the Collector app, you download and sync. What this does is it enables the locator information from Arcgis to determine your spot. And when you do this, you want to make sure that you've got the Wi-Fi and the auto sync on. Then you're going to click onto this thing that says Mill Creek water sampling, and you're going to drag it up into this gray box. Then you'll come up and you'll see this is your site, and then you'll fill in all this information if you want, or just take the pictures. And then once you're finished, you'll hit submit, and this will actually go straight to our website. You'll be able to actually go onto our website and look at what you put in. The output, this is the output on the map that's on our interactive map. And then it'll give details that look like this, and then it'll generate points like this on another map where our water chemistry data resides. There are tutorials out there for this, and I gave you a link to one of those on your handout. So that was a lot for me to cover, and I feel like I just talked to myself looking at this screen, so I'm going to see if I can't come back to all of you. Does anybody have any questions at this point?
Yeah, I was. That's what you mentioned about doing the extra sampling or collecting data for the MSD.
And the Midwest Biodiversity Institute, yeah.
Yeah, I'd be interested in doing that.
Great, Andrew. I'll put you on the list. As I say,
Okay.
we'll be planning. We're going to have to find a date that doesn't fall in another Mill Creek activity, so it'll probably be in August.
Okay.
But we'll just go out once and bring them all back.
Okay. Yeah, sounds good.
It's going to be fun, and as I say, I'll be sharing all of the biological information MBI gets with you guys to see, because Ohio is a biocriteria state, so we're going to be looking at their indexes to see. That's how you determine if you're meeting your standards and your designated users. Okay. So we'll talk about that.
Yeah, that sounds really fun. Yeah.
So what about the rest of you? Has anybody got any questions? I know I covered a lot of ground in a very short time.
And Jim asked a question if or how they'll be able to access this presentation at a later time.
Good question. I am recording this, and then I'm going to work with Linda Keller to put it on our website. And once it gets there, I'm going to send out an email that everybody knows about, and you'll just be able to double click and it'll go to the cloud, and you can run this like a video. Any other questions?
Yeah, I actually had a small question. Right now I don't have like access to a car. So I was wondering if is there any way I can get an access point or like a water sampling location close to where I live, like within like 5 miles or so?
Yeah, I'll work with you on that. Some of the teams also, people got onto a bus and met them somewhere. So,
yeah, I can do that too. Yeah.
So we'll take a look at how we can make that work for you.
Okay, thank you so much.
No problem. Any other questions? It's weird not to see your faces. I can usually tell if people are confused if I can see you.
Signing up for lab volunteers. I'm going to try to get up there as much as possible this year.
Fantastic. If you are interested in being a lab volunteer, and some of you said that when you registered, and some of you said water sampler, and I haven't really talked about what's next, and he's reminding me I should. You have a choice if you want to be a lab volunteer, you want to be a water sampler, you want to be both. And I have some new volunteers, and I've got you in a separate list, and I was waiting until we had these trainings. I'm going to send out an email to all the new folks, and I'm going to let you know which teams need water sampler help. And you can take that map, and you'll see where those sites are and how close it is to your house and that kind of stuff. You can tell me which team you would like to join, and I'll put you in touch with that team leader. If you want to work at the lab, you have a handout in those handouts that I gave you. That's a water sampler handout, and if you open it up, it's got the address for our lab, which is 6055 Center Park Drive in Westchester 450 I'm not sure. I know it's 6-9, but I don't know what the next one is. That's on that handout. And that tells you how to get to the Upper Mill Creek Water Reclamation Plant. But on that handout, what's also useful is it's got a little inset map that shows you where on the property we are. So if you come in the gate, you're going to make a left turn, and you're going to stay on that left loop, and then you're going to swing around and it's going to turn right. You're going to see a couple of buildings. Our table will be sitting out between those two buildings where you do the sample drop-off, so you'll be able to see people in there. And then we have samplers in 3 different spots in that building so that we observe that 6-foot COVID rule. But everybody will be in a room with somebody else. You won't be by yourself. But we have this 8 different stations set up inside. And we'll teach you on the job the sample station you want to be at that time, and you can switch or you can stay on the same. That's really up to you. But all of the lab folks will train on the job. It's much easier if you can sit at the piece of equipment and actually do it when you're trained. So I'll be sending that email out, and hopefully I can get you assigned to some of the teams that really need some new members. Any other questions? Well, if that's the case, we finished in an hour. It's 7:30. So you're always welcome. If you have a question, you can shoot me an email, you can shoot me a text, and I'll try to get back with you as soon as I can. Keep in mind I only work 25 hours a week, so if you really want to get a hold of me, call my cell phone or text my cell phone, because I always have that with me and I don't always have my computer up. Any other questions? So if that's the case, I'm going to let you get back to your evening, and I want to thank all of you for taking time out to come to the training, and I'm looking forward to meeting you in person and just working with all of you this year. So thanks.
Thanks, Sam.
Thanks.
Thank you.
Take
You're
care.
welcome.
Sam.
You're welcome.